This video is to go over a few things about graphing piecewise functions. So I'm just going to start off by basically creating an example to warm up. Now here I just sort of set up a little piece of a graph. I have my x and y axes all set up. I'm just going to go out a few units in each direction, so nothing too crazy. Now to get us started, I'm going to use, say, maybe a linear function and a parabola and then absolute value function. So I'll make this have three pieces to the piecewise function, and really all you're doing is drawing a piece of a function, and then you are indicating the domain, which we have just posted a video on domain. We're indicating the domain for that particular function. Okay, so let's say I start over here, and I'm going to make this my vertex of an absolute value function. My absolute value function, if you remember from algebra, it looks like a v when it's the absolute value of x, because basically it's taking a linear function and taking any part that was under the x-axis and making it positive, which bends it into a v. Now, I'm not going to change the stretch or compression, or maybe you call it a slope. I'm going to leave it with a slope of 1 on the original, so that means that I'll have a slope of -1 and 1 on either side of the vertex. So up 1 over 1, up 1 over 1, and so on. Now, if that's all I have, and then my absolute value function stops right here, when I'm writing my function out as f of x equals like this, I need to sort of show that it's only running from -infinity until -2. So I'm going to write it a couple different things down here. Here, I'm going to write my absolute value function. This is moved to the left 4 units. That means you'll have +4 inside of the absolute value bars. My vertex is then moved down 1 unit, so I'm going to have -1 down here on the outside of the absolute value bars. Next, you might have a comma, or maybe you'll have the word for, or such that. I'm going to use a comma. Now I could write a couple different things. Some people may write with an inequality, x is less than or equal to -2. But some people may use interval notation, which would look like -infinity, comma, -2 with a bracket. Either way, totally acceptable. For the next piece, I'm going to make it a little easy. I'm going to use a linear function, and I'm going to make it such that the linear function will cross through the y-axis at a nice spot. There we go. And I'll stop right here. Okay? So I can use y equals mx plus b, which is slope-intercept on the line, to write the equation of this piece of the function. Now, if I use mx plus b, my slope, if you look carefully, is -2, so it's -2x, and then my b, which is my y-intercept, will be +1. Now, here, I only have a graph of this linear function. There's not arrows on either end, so I only have it between -2 and +2. So maybe we write it as a compound inequality. X is less than or equal to +2, and it's greater than or equal to -2. Oops, actually, I have an error here. So if this is closed, then that has to be open. So I'm going to go right here. Otherwise, it won't be a function. I can't call it f of x. It'll fail the vertical line test. So I'm going to leave that one open. So that means I'm going to go over here and erase that little equal sign right there. All right? So I can write it like that. Or, again, with inequality interval notation, I can write parentheses -2 to bracket. And for the last piece, I'm going to use a parabola. So for this parabola, let's do something right over here. Let's go. Put my vertex there. Let's say I have it opening downward. We go out 1 and down 1 in each direction. And then I'm going to go out 1 and down 1, 2, 3. That gives it a 2, 4 movement, which is good for a parabola because 2 squared is 4. And if you need any explanation on how to graph a parabola, you could do that separate video there. I know you didn't already have one posted. And right here. Okay, so there we go. And ooh, a little smudgy there, sorry. There we go. So that parabola moved to the right 4 units, which means I have an x minus 4 inside. There's no stretch or compression, but there's a reflection, so I have a negative out front. And it was moved up, ooh, and obviously I need a squared if it's parabola. Then I need up 6 units, right there. And my interval that I have this on, this domain in inequality notation, will be when x is greater than 2, or we can write that as being from 2 until infinity. So that was just building an example of one to kind of give you a better understanding of how piecewise functions work. And sorry, I'm just cleaning up that smudge a little bit. And now let's do some practice. So let's say we were being asked to graph this function right over here. First thing I like to do before I even draw axes, more often than not, is I like to kind of just look at what I'm working with and look at the restrictions I'm given. I'm being asked to graph this first piece between 0 and 10, and the next piece when x is greater than 10. Now I went out about 19 over here. I really don't need any of this, and hopefully it makes sense based on what you're given. So if you're giving multiple choice, then you can eliminate anything that has graph in that area. Your answer should only have graph on this side, okay? If you're drawing the axes yourself, you do want to refrain from even wasting space drawing this, okay? Next, since they're both linear functions, then I'm not going to be having any turning points. It's not like my graph is going to be going up and down or anything like that. So what I'm going to do is I'm actually going to rewrite it down here. I'm going to write it a little differently and think about plugging in 0 and 10 and what that will do, just so you have a different way of looking at this, okay? Because I don't want people to always think of this as y equals mx plus b, because if, for instance, this one, x is greater than 10, you're not looking at the y-intercept. You're starting at 10 and going on from there. So I'm just going to rewrite this. I'm going to color coordinate a bit. So f of x equals, let's use some red and blue, 0.5x. Well, that's really 1/2 x. My slope is rise 1, run 2, x plus 7. And just for a little variety, I'm going to write that from 0 to 10 like this, just to change it up. Now, if I plug in 0, it's linear, so it's straight, it's a line. If I plug in 0, I'm going to get 7. If I plug in 10, half of 10 is 5, and 5 plus 7 is 12. So again, this graph in red, okay, is going to have which points on it? Sorry, 0, 7, and it's going to have 10, 12. So 0, 7, 2, 4, 6, 8, oops, that's 8, so 7, and both were included, so that could be solid. And then the next one was 10, 12, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 12. So it's going to go, that's 10 right there, from here to there with a straight line. Now, could I go over here and go up 1 over 2, up 1 over 2? Yeah, look at that same line, but the shortest distance between any 2 points is line. Why not find that first point and that last point, since we're on a closed domain? Closed domain means it doesn't go on infinitely in either direction, so this is a closed domain. Why bother when you can just find the 2 endpoints and connect them? This only works for linears, because if it were a parabola, you wouldn't know exactly how to draw it. Now, the next one is 2x minus 8, really, and that one goes from, oops, this goes from 10 until infinity. Okay, So what I'm going to do now is plug in 10. If I plug in 10, 2 times 10 is 20, and 20 minus 8 is 12. Oops, should have been 10 times 12, sorry. 10, comma, 12. Now, coincidentally, these are the same points. So where that one was closed, we're going to have this one be open. And normally a choice isn't going to have color-coordinated options, but this one does. Now, really, when you have a slope of 2, that means up 2 over 1, up 2 over 1. You don't have to start at the y-intercept. You can start at any point. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Now, you have to be the conscious decision maker and decide, which approach do I want to use? Maybe you want to plug in another number and then just connect the 2 dots and draw your arrow. This one will have an arrow because it's not a closed domain. It goes on forever to the right towards infinity. But that's up to you. You need to choose the option that's going to be best for you. So again, that was 7 on the axis there. This is 12 on the axis. That ordered pair is 10, comma 12. This ordered pair is really 0, comma 7. If you're giving a point or an ordered pair, you have to write it as an ordered pair, okay? You don't just write a random number. If I were labeling this point as an ordered pair, I'd write 10, comma 0, all right? So something like that. One more sample to practice. Now in this example, what if you are given a graph and you're asked to write the function? So kind of in reverse, just a little, make sure you understand. The red is a parabola. It's opening upward. I don't need to write it in standard form. I could definitely write this in vertex form. I move to the left 3 units. Now, hopefully you hit pause and you tried this on your own first. If not, hit pause now and take it up from there, and then press play when you're ready. Squared, otherwise it's not a parabola, it's a line. Then it moves up 1 unit, and now I have to say where this parabola is in existence, and it's from negative infinity until -1 closed, -1, and that will be in brackets. Sorry, my dog is very high maintenance right now. I'll get to him in a second. Next, in green, you have a linear, but it's got a slope of 0, so it's really constant, a horizontal line. What number is it? G equals 2. G of x is the y value or the output. It equals 2. Where does it equal 2? From -1 until 2, and the 2 is included. And then in blue, what do we have? We have a linear function, and it looks like my slope is down 2 over 1, 2, 3. So I definitely have a slope of -2/3. Okay, I'm not going to use mx plus b right now. This is just another way to do these. I'm going to use transformations and move to the right 2 units, so -2, oops, the x, -2. And then I moved up to get to this point. And really could use any point on line. I could use this point, I could use that point, whatever. I moved up 5 units. So now I kind of did it like my vertex form of my parabola. But now I have to set my domain, and my domain, comma, my domain is going to go from 2, not including the 2, until infinity because of that arrow pointing to the right. So there are a few examples of piecewise functions, and hopefully you have a better understanding of those now. Good luck.